Wow. Welcome to TWF. As we were saying, I'm John Rabasa, Creative Director at Infusion.
And I'm Jeremy Bibby, an architect here in Infusion as well.
Everybody having a good conference so far? Well, anyways, today we're going to talk about the HoloLens and specifically what it is like to interface with holograms. We're going to talk a little bit about where the HoloLens fits within the spectrum of virtual reality and augmented reality. We're going to talk a little bit about what makes a really good experience. And then we're going to leave you with some tips to create your own HoloLens app.
So Infusion is a technology and design firm. We have offices around the world. So as was mentioned, I'm based out of our Toronto office. John is based out of our New York office, and we obviously have a very large office right here in Krakow, who's graciously hosting this conference.
We have a wide variety of services and practices that we offer. We cover many different technologies and many different kind of professional services that we do for our clients. One of the ones that Jeremy and I are involved in is emerging technologies. We've actually been able to have our hands on the HoloLens for about almost close to a year.
And the vehicle for that was the Microsoft HoloLens Agency Readiness program. So Microsoft invited 6 of their kind of closest agencies to Redmond to go and talk with the engineers and designers who have been responsible for the creation of the HoloLens. They've been working for the better part of 5 years, and they taught us everything about that they've learned about how to create great holographic experiences. And what's to note is we're the only partner who has any European presence.
So a lot of the tips and techniques that we pulled in have allowed us to create some applications in the future of advertising for consumer packaged goods, molecular envisioning for pharmaceuticals. We've done work for retail and for banking. For each project, we've learned new things, even though we got a lot out of the program. And we're also there to help our clients, our businesses, figure out what makes sense for them to, how the HoloLens will help them in their business interests. So let's pull it back a little bit and talk about the HoloLens and with regards to virtual reality. So we've been waiting for this a long time, at least I have. I'm a little older than a lot of folks out here. So for me, it was always been about like a great amount of expectation and then not a whole lot of fallback. But I think things are different right now.
And to explain why they're different, we really have to look at the past and what's happened in the last few years. Stereographic vision is not a new phenomenon. And in fact, there have been examples going back to an exhibit in Paris in 1844 of demonstrating 3D vision through projecting different images to different eyes. And it's gone through a lot of revisions. You can see on the stage there, one of the early cameras, which had 2 physical cameras to capture film, which was you can play with those red and blue kind of lenses. The problem with this content is it is static. It was produced from a fixed angle, and you couldn't look around. You couldn't see more. To enable that, we really needed to look at what are we trying to achieve with this, and what we actually want to do is to represent 3D objects and translate them into a 2D plane, which can be projected into your eyes. So in the 60s, a lot of the mathematics of this were developed, and you see there our favorite tea kettle, the actual object, and what we kind of associate with Maya. And the beauty of this is that it allows us to create 2D images on the fly based upon a particular camera position. But the problem with this approach is, obviously, it is computationally expensive. And with some of the early hardware, and particularly the hardware we had in the 60s, this meant that rendering things took hours to do. According to Moore's law, however, we've seen the performance of GPUs explode in the last few years, and that not only affects the high-end GPUs, but it also affects some of the lower-end devices. And in fact, your modern cell phone has about the same computational power in terms of floating point operations as a top-of-the-line graphics card from 2008. So you're starting to see a lot of movement on both ends of the spectrum. And to complement this, we've also seen a huge influx of low-cost sensors. So they encompass a wide range of different things they sense. So on the HoloLens, you'll notice that it has infrared sensors, which allow it to understand the space you're in. It also incorporates things like IMUs, which allow it to sense motion, use gyroscopes to understand the position and orientation of the device, compasses. All of these sensors used to be very large and very expensive, but now they can be incorporated onto even low-cost devices. And the final piece of the puzzle is these stereographic displays. So when we look at the HoloLens, when we look at the HTC Vive, we see displays which are able to incorporate some of those very early ideas of stereographic vision, but couple them with the 3D power enabled by the GPU and bring in the sensors for head tracking, hand tracking, and really create these immersive environments.
So the technologies come together and the business community's taken notice. There's wild predictions, anywhere between 16 billion to 150 billion by the year 2020 in terms of an overall business for hardware and software. Goldman Sachs tends to play a little bit in the middle, and they've broken it down by the graph that you see. As you can tell, most of it is the predictions around video games and entertainment content, but almost every sector is represented here. So what it means is the hardware is here, the software is here. Gartner has published this, peak of expectation and trough of disillusionment graph for a while. And at this point, we're kind of say that, the technology is ready. Virtual reality followed by augmented reality is coming into the mainstream. So back up a little bit. Let's talk a little bit about some of the terms that we're using, Jeremy.
Yep, absolutely. So when we talk about these different types of experiences, be it on HoloLens, be it on Oculus, you're starting to hear a lot of different terms between virtual reality, augmented reality, and now the new player, mixed reality. So we thought it would be important to understand what each of these terms means and what type of experiences are best suited to each of these types of experience. So on the one side of the spectrum, you have virtual reality. So I think that we all know virtual reality pretty well. It enables things like the Oculus, and you see that on this side is kind of on the right. On the other side, you have things like the Google Glass, as well as phenomenons like Pokemon Go, and these kind of represent the augmented reality type experiences. But what we're really interested in is something in between these, and that's what Microsoft is calling mixed reality.
Okay, so just a quick definition: virtual reality, and we'll use the term VR, is a completely immersive experience. You put on the device, sometimes also you cover your ears, and you're essentially transported to a different world. It's done through a lens, audio, and also there's head tracking. So for those of you guys who haven't experimented, there's some Oculus out there, and it tracks your movement of your head, and you get the sense that you're perceived. What makes this a powerful technology cuts you off from the rest of the world. So it's very immersive, but it means that once you're inside this experience, you're basically not in the real world. By contrast, augmented reality is supposed to take place in the real world, and augmented reality means you're bringing in, you're augmenting it with some sort of data layer. Technology that we've seen in the past have sometimes been keyed off of an image, so whether it's a phone or tablet, I use an image to recognize and bring some sort of additional layer, or like the Google Glass, where maybe I'm using my location and stuff. But essentially, I'm not really interacting with the world, I'm just sort of bringing some extra information into the world.
Which brings us in contrast to the new concept of mixed reality. Mixed reality really is about introducing real-scale holograms. And so what I mean by that is that you can have visual elements which are not merely kind of positioned over your world, they're positioned in your world. They're represented at true scale, and what that allows you to do is to have your environment act as part of your interface. And that's helped by elements with such as directional sound to allow you to associate the audio cues with physical objects, as well as a rich concept of spatial mapping. And what that means is that you are able to understand exactly about the space. We're going to go into these a lot more detail, but these are some of the differentiating factors of mixed reality compared with some of these other factors. But you may ask, why mixed reality? What's important about it? Why are we as Infusion and the whole community really excited about this technology? And the answer is that by combining the elements of augmented reality with augmented virtuality, you're able to create a sort of magic. You're able to create scenarios which are impossible with either of the two types of scenarios. So what that allows you to do is it allows you to collaborate with perspectives. So you see in the background image that the designer there is able to conceptualize the motorcycle in their CAD software, but can also see it right there on their desk and in full scale. They're able to use 3D and 3D, and it really allows for some innovative scenarios.
Let's take a closer look at the HoloLens specifically. There are basically three key elements to the interface. There's gaze, gesture, and voice. Gaze is, by the way, the most important part of it is it's what sets the context. As you look around, the HoloLens is being tracked, and whatever you're looking at, that's what you're basically actioning. So imagine that it's essentially kind of like your mouse, and when your mouse hovers over something or displays something, it gazes how it knows that you're ready to sort of take action on it. Gesture, Microsoft wanted to make the HoloLens very basic and easy to understand for the consumers, so they very much restricted the gesture language to essentially what would be the equivalent of a mouse click. So there is tap, or there's tap and hold. And that's it, that's your language. So the Minority Report thing where you can sort of expand and zoom, not part of the interface at this point. They want to keep this very perspective. There's one extra gesture, which we don't have to go into it, but it's called a bloom, and essentially it brings you back to your home state. It's kind of the equivalent of if I had my phone or my tablet, I'd press the home button. Oops. Did I skip it? No, fine. Sorry. Voice is actually really important because gesture is not a very intuitive, sometimes, a way to interface. Voice becomes a key into it. So just like Cortana or Siri or Alexa, the devices it's listening to, there's 4 microphones, and it's able to basically recognize what it is. So some of it you have to do in your code, but it could either recognize keywords or complete grammar. This is essentially kind of a big piece of how to create good interface design.
And to add to that, the 4 microphones allows it to do a lot of the audio processing, which would normally be prohibitively expensive. So it eliminates all the background noise, and you actually have a really clean audio feed. But that brings us to our last kind of differentiating factor of the HoloLens, spatial mapping. So using these IR cameras, the HoloLens is constantly creating a live 3D view of your room. It does so by creating a point cloud and then using some custom hardware to create scans, kind of like you see here. Not only does it create the scans, it is also able to place itself within this world. So you can place something like you have a wedge head placed here, and you can walk around them. And because the HoloLens understands where it is within the space, it is able to kind of correctly orientate it. Another thing to note, though, is that these meshes are actually saved within the HoloLens. So if you map a space, leave that space, and come back, everything which you place there will come back. So the idea is that these spaces become part of your interface. Which brings us to a quick slide about the technology stack. So I hope you'll join me tomorrow for a more in-depth talk about the tech stack. But what's important to know is that the HoloLens is a full Windows 10 PC. And what's nice is that the technology stack and the development stack is actually made in such a way that anyone can get started for free. So Microsoft has released a HoloLens emulator, which is free. There's a community edition of the Unity engine with holographic extensions, which is free. You can use the community version of Visual Studio, which is free. And then finally, they've introduced a open source library which encompasses all sorts of great goodies, which help you to design your own holographic applications, which is called the Holo Toolkit.
So while Jeremy's putting on the HoloLens, some of the things that you have to consider when creating these applications. So these are some of the gotchas. First, because the device is essentially mapping the space and is using infrared technology, it only works inside. It doesn't work outside. Natural sunlight is too powerful and blasts it out. The other thing to consider is that you're essentially wearing a mobile device so that you need to kind of balance your performance and your power. So it's different from creating like a game for a desktop where you have a lot of power and a lot of computation. Here you're more creating something that you would do for like a tablet or a mobile device. There's something that you may have heard called the field of vision. Essentially what that means is that when you put on the device, you don't have peripheral vision. You're pretty much looking through very focal points. So whatever you look at, you have to be focused on that. There's some considerations in design to take that into account. You do get used to it, but for some people at the beginning, it seems like the expectation is that I'm seeing something all around. Because it's stereoscopic, you want to be able to create your holograms so they're about 1 meter away. Too close, and your eyes have a lot of discomfort, and so you want to keep that in mind. The devices are set for kind of what's kind of a standard, but everybody's eyes are different, so you can calibrate it and increase the comfort. Finally, like as I said, battery life and usage time. Not only is battery life about 5 hours, right? But usage time, these experiences can be a little taxing at first. So, create an experience that's not too long. And also in terms of being taxing. So gesture interfaces can be tiring. So you want to kind of balance what you want people to do versus what you may want people to speak on. I think, are we ready to do a demo? All right, awesome. So we're going to switch a little bit out of our PowerPoint. This, what we're showing you next is part of what you get with a device. This is a web portal, and this is called the mixed reality capture. So what you're seeing is what Jeremy is seeing. So earlier in the day, we came and mapped the space. We put some holograms in space. One of the attributes of the HoloLens is that you can put your apps in different locations, so against a wall, on the floor, and it will remember that that's where they are. This is actually the 3D video that was taken, and it's it's actually an instructor showing how to properly lift this. He actually does he does pull it off. He does get it up on his thing. Are you able to show Galaxy Explorer?
Absolutely, John.
So there's a little bit of a lag between what Jeremy's seeing and what we're seeing on the screen. Galaxy Explorer was an application that Microsoft sent out for different ideas. The community voted, and it's actually a really good representation of the kind of experiences that it really takes advantage of the fact that you can have this infinite sense of scale and zooming. There's a very simple interface, for buttons, but most of it, you interact with the object itself. Anyways.
Yeah, and we really like this application for a few reasons. First of which, this is an application which was done in only 6 weeks. It was done by a team at Microsoft, and what's nice is they published, kind of their process and all the kind of steps and decisions they took online. But more so, this is actually an open source project, so you can download it from Git and see what goes into these holographic experiences, and it's a great launching point for building your own holographic applications.
All right. Thank you, Jeremy. If we can go back to the presentation. The HoloLens is going to be available out there. People can take turns and actually, actually get a real life experience. But I hope that was good and useful. So my passion is experience design. So I want to talk a little bit about what it is to actually think in terms of 3D interfaces. We've actually, up to now, we've been actually thinking in terms of, unless you're in game design, we've been thinking in terms of like 2D and how to, translate 2D and, how to create great interfaces within 2D. Whenever we face a new technology, Marshall McLuhan always comes to mind. He had this great notion of the rearview mirror, which is that whenever we go into something new, we don't have any context for it, so we apply what we do know. When the TV first came out, the early programs were just radio programs. People would just get in front of the TV and talk because that's what people knew. It took a while to develop that language that's now very mature and rich in terms of like how to create great TV content. Same thing when the internet and the web first came out. People were trying to figure out, is it a magazine? Is it a brochure? Is it TV? And I think finally, that medium is very mature. We're in the same stage right now, I think, with holographic interfaces, where we're feeling our way around in terms of like what makes sense. We have some precedents. So first of all, even though we're talking about 2D and 3D, we've been representing this stuff for a long time. And we've represented it both in an abstract manner, where I have something that represents, for example, a woman, both 2D or 3D, or I have something representational, which is like, here's a specific person. This is kind of what lays the ground to what has been an evolution of a lot of our interface design in modern times from the first GUI. So not the first GUI ever, but the first GUI that a lot of us experienced. I had this Macintosh, and it was great for us to be able to think in terms of what was going on in the computer with real-life concepts, real-world concepts. We had the trash can, the file system. These things helped us sort of understand how it is to operate this medium. But sometimes we take too long. We fetishize this stuff. So this is Roz's second startup that he did, for PDA. And here he's really taking that real life concept like a little to the edge with like, okay, my Rolodex for contacts and my agenda for my calendar and an inbox and an outbox. Things start to kind of fall apart a little bit. And I don't know if any of you guys remember the example from Microsoft Bob, where it just really starts to, the whole real world concepts now really starts to take over, and it's no longer really practical or useful or even attractive. So some of you have heard this concept of skeuomorphic design. Skeuomorphic means you take a real-world object as a representation for a software, for a piece of it. So in a button, if I make something that looks like a button, the expectation is that maybe it performs like a button. At a certain point, we don't need to have it all represented because we know the abstraction of what a button does. It sort of looks like this, it has a label. So we can balance between the two. I think skeuomorphism really helped in the early days of iOS, where people were getting used to natural user interface with touch. In the example of the calculator, that really works because I have the buttons placed where a real-life calculator is. I have a screen. It all makes sense. There's a good translation between the real-world object and the software object. But again, our tendency is to maybe push it a little further, where we do things that maybe are not really necessary, like page turns. In a book, it's kind of like tolerable. But then when we got to things like the address book with tabs and things are just no longer not really necessary, and things tend to give skeuomorphism a bad name. So I relate this because I want to talk about what our expectations are when we design holographic interfaces. On one end of the extreme, we would love it to be like this. We'd love to come into space and have the whole space turned around and have us interact with holograms in real time. But we're also kind of worried that we more look like this, that we're actually, very dorky and it's very cumbersome and the whole thing is sort of falling apart. Fortunately, I think we're somewhere in the middle. It is a continuum. Deloitte published this. Deloitte published this graph, which I think represents kind of our ideal situation with interfaces, which is on one end we deal with computers through hardware and software. So between us and the experience, there's a couple levels of translation. As we moved into mobile and touch, and as we went in as we're now really getting into voice, those those layers are starting to collapse. And ideally, we would just have a situation where we are within the interface itself. I want to talk a little bit about some really good examples of the kind of applications we see in the field in terms of taking advantage of this medium. Not all of them based on mixed reality. In fact, they play within IR, VR, and MR. But
absolutely. So the first example is something we've seen a lot of applications for. To John's point, both within virtual reality and mixed reality, and that's training applications. So at Infusion, we deal with a wide range of customers who deal with some very dangerous industries like oil. Oil and gas has lots of training scenarios which need to be relayed to employees, and simulating scenarios like head gaskets blowing and oil rig fires are very expensive or impractical to simulate. So using technologies like virtual reality, they're able to simulate these scenarios in a very cost-effective way and a very repeatable way. And the second example we have is controlling the Internet of Things. The Internet of Things is blowing up now, and we're starting to see devices everywhere with the Internet connectivity. So using HoloLens or mixed reality, we can start to envision presenting controls for these IoT devices. And what you see on the screen behind me is an IoT robot, which actually uses a hologram as its user interface. And not only that, it's also able to use information from the HoloLens in order to inform decisions. So you can point to a space in physical space, and it can translate that to a series of movements for the IoT robot. So it really allows both those ways of communication.
A really great and exciting way for, especially for the HoloLens, is because you're not blocked, you can actually be in the same space. So when Jeremy was wearing the device, he may look a little bit like Cyclops from the X-Men, but he's actually seeing us, and if I were wearing a device, we would be able to converse and talk to each other. But more importantly, we're also collaborating around the same 3D object in space. So we can walk around it, we can have the same perspective. You can do this between HoloLens to HoloLens, HoloLens to other devices. You can extend it to across, so you may even be able to do it like you guys did with the mixed reality capture. Related to collaboration is the whole notion of 3D presence. Some of the apps show people interacting in the same space, but we also like to see them interact over large amounts of distance. So be remotely present either as an avatar or as these new technologies are coming where you actually may have a real life representation of yourself.
Absolutely. And to build upon that, we've also seen a whole class of applications which combine some of the elements of mixed reality with the desktop applications which we have experience with. One great example which we've seen is the collaboration between AutoCAD and HoloLens. So using one of the next revisions of AutoCAD, you're able to project content from any CAD drawing you have into the HoloLens. And what that allows you to do is to have teams, and teams who might have creative people, might have engineers, who are all able to see the same 3D vision at their own perspective. And it allows for much richer collaboration between people rather than just kind of two flat screens. And the last kind of example we have is around spatial awareness. Because we have these great sensors in our devices, we're starting to think about a lot of applications where you can use that information to inform your application. So that could be something as simple as a furniture placer for IKEA, or equivalently, it could be something that an insurance adjuster might use while going around and inspecting properties. Anything which relies upon digitizing the physical space into something consumable in the kind of computer. And what that has led us to do at Infusion is to try and look at the different types of applications and 3D situations we have. So over here you have kind of a listing of what we presented, and we've kind of characterized the suitability of these experiences for VR, mixed reality, and augmented reality. And what we found is that mixed reality really allows for representing these rich 3D visuals that you might expect for virtual reality, but also allowing for kind of the collaboration which you might expect as part of an augmented reality application. So it really is the sweet spot for us, and we're really excited about a lot of its capabilities.
So to summarize, when you're creating a holographic interface, you are going to be using both representational objects as well as abstract objects. You're going to be able to use 2D and 3D graphics. You're going to be able to use sound, both the sound that you hear as well as the sound that you project. Most importantly, you use all these things because they all are part of your space. So whether it's a peripheral like a second computer or not, the main thing that you pull away from it is that mixed reality is when the space itself is the interface. One of the things that we've noticed is that when people place holograms around, and they remember them, so they no longer have to navigate a series of menus. They know that, for example, the puppy was over here and the refrigerator app was over there. The space really becomes part of how you conceptualize and how you interact with the application. So speaking of applications,
yeah. So we've talked a lot about abstract concepts about what is a great mixed reality application, but what we'd like to share to finish off is how you can take those concepts and create a great application, and the process which we have found really helps us to enable these scenarios. So in the traditional software development design process, even if you're using an agile flow, what we found is that it tends to be a pretty linear process. You have an idea, you get requirements around that idea, you do your designs, and then you do build. And then it's your next sprint, and you kind of rinse, lather, repeat. But if we contrast it to the new process we're seeing here, it is a little bit more of an iterative process, even within a sprint. So what we're finding is that, sure, there still is the ideation, there still is the definition. The definition is a little bit different from design, which I think we'll get into. But then we build it, and then there's this whole, test and refinement cycle. This is a much more critical part of the software development process. So we'll explain a little bit about what we mean by that.
There are a lot of people who can come together to create holographic apps. Essentially, there are three key roles. You have your artist role. This is a designer or 3D modeler, animator, the person who's actually going to either acquire the assets or develop the assets, both in terms of 3D, 2D, even sound design. Then you have your Unity developer, designer. Unity is a gaming engine. It's the gaming engine that is used to create HoloLens applications. Essentially, it's an abstraction layer that lets you apply physics and organize your construct in a 3D environment. And last, of course, you need software developers that are going to tie into back-end services, do other sort of integration. They're the ones who sort of build it so that it becomes an app that uses either real data or real systems in place.
Right. So we've broken up the development process for a HoloLens application into 5 simple steps. The first step is to really find your use case. So use cases for HoloLens and mixed reality, as you imagine, are different from what we're used to. So when we're looking for an ideal use case for HoloLens, what we like to start out with is trying to think about what are the problems that we are trying to solve in 3D space. The ones that work best are, where the problem is 3D in nature. Some of the most obvious applications of this is, if you are dealing with a physical property, a physical problem. So, if you can envision, an architect trying to design a building so that the reflections don't, cause a death ray like in London. That's something which is a very obvious 3D problem, which is a great opportunity. Similarly, in the world of finance, we deal with data which is very multidimensional. We understand how to represent in 2 dimensions, but imagine if you can go and use the 3rd dimension to represent, an order of magnitude more data at the same time for traders. Think of the possibilities and kind of the trading desk of the future. And the final one is, you do have a device which isn't blocking you off from the real world. So use that. Go and look for experiences which can use collaboration between teams of people, either wearing a HoloLens and one person wearing a VR. Try and find scenarios where you can get people talking with one another. We're stuck behind our screens now, and we can get rid of the screens. So that's kind of the kind of greenfield solution. But we've also found that it's very possible to augment your existing line of business applications. Now, this one is a little bit tempting to go and reproduce your 2D application in 3D. You should still follow the same process. You should still go and look within your 2D application for what things are inherently 3D. So in the case of AutoCAD, it does have 3D models, so those are the obvious kind of catalysts for that. They didn't try and reproduce the entire menu structure. There are some things which will work better in 2D. There are some things that work better in 3D. So you should look through your existing application and see how you can bring in 3D, how you can bring in collaboration. And then the final part of this is, to really understand where you want your application to live in that spectrum of virtual reality to augmented reality that we laid out before. You might find that some aspects of your application might work better in virtual reality. Some might work better in mixed reality. What's nice is the tool set, the Unity tool set that we use for HoloLens, is very compatible with these VR systems. So even within a lot of the applications we've been building, we're starting to think about what facets make sense in virtual reality, what facets make sense in mixed reality, what facets make sense to keep within 2D. So think about that when you're trying to find your use case.
So now that you have a use case, you want to start to codify your functionality, or essentially just what is it that you're hoping to make? One of the practices that we pulled away from Microsoft is, rather than creating very long requirements documentation, is to really simplify things, especially because you remember you're going to be working this very fast iterative approach. So the first thing you want to do is write the one-line concept statement. Think about, it's actually harder than it seems to put something very succinctly, but to think about how would I describe it to somebody in a sentence or two, so they understand it right away. What is it that we're trying to accomplish? So in the AutoCAD, it would be, I want to share a view of my model within my engineer in real time. Something, so better said by others than that. The other part of it is keep your requirements simple by thinking in terms of a 5x5 matrix. So what are the 2, 3 to 5 top features of your application, and what are the 2 to 3, 5 supporting bullets to those features? So if if your feature's broken down to one lines, what are the 3, 5 bullet points that can support it? The last is, for those that are more on the design side of things, is that you really need to sort of sketch it out. So you take a page from movie making or game making, where instead of trying to reproduce your UI, you think in terms of more, how do I sketch out and storyboard the experience? So here's an example of one of the things we were sort of envisioning, where you basically want to storyboard out all the steps of a user journey, of an experience, and how are people using it. What's the sense of scale? Who's where? Who are the different kinds of users? It gives everybody on your team an idea of more or less how things are coming together. You want to basically represent what's holographic and what's going to be in the space and what's in the real world.
Yeah, and by codifying that functionality, what it really allows you to do is to have a clear stick in the ground about what is really required for these holographic experiences. So we talked with the Skype for HoloLens team, who did write their one-line concept and their 5x5 feature matrix, and those were the requirements for a 3-year program. So that helped them to narrow the features to what is explicitly required and what would be powerful, and really helped them to describe it both internally and externally. So after you've done this codification, the next step is to actually build your application. So the first step that we take when we're approaching a new problem in 3D is rapid prototyping. So what rapid prototyping can encompass could be anything from as simple as creating physical props out of styrofoam and cardboard to represent the scale of your objects. It could be making quick prototypes in Unity and pushing to the HoloLens. It could be importing OBJs into the built-in OBJ reader. Anything to be able to understand whether your vision makes sense and whether it'd be useful for your users. So after you've done so, the next step is to increase fidelity. So by this, I mean, if you have, just a box representing the model, like, obviously you can improve that model and improve the vertices, improve the definition. Similarly, you can introduce animations. You can introduce state to your objects. So keep on iteratively increasing the fidelity until it's somewhere, kind of appropriate for what you're looking for. But keeping in mind that you do have a performance budget. So for anyone who has done Unity development, or indeed mobile development in general, you'll know that, hey, you are limited in the number of polygons you can push to the device. It has roughly the same computational power as a high-end tablet. It actually has an Intel Atom processor for that stuff. So what it means is that you need to be careful about how many polygons, be careful about what shaders you use, and just try to keep that in mind through the entire process.
And of course, we've mentioned this many times. It's basically a wash, rinse, and repeat cycle. You start with very raw forms, and you sort of kind of polish them and working together until you finally find that this is the state where you want to push out. I can't say this enough that what you imagine when you sketch, what you put into your 3D program, often takes you by surprise when you actually load it into the HoloLens and you see it in your real world. Things of scale are just very different. Certain types of objects just feel different. For example, pointy objects tend to create a lot of discomfort. Things that are sort of like blockish and square look very heavy. There's a lot that you just sort of can't really translate until you experience it yourself, and then you go through the process and let the whole team, which is one of the reasons why we have this model of like just build it crudely and just keep refining it until you get the right app, and then hopefully now you're ready to launch, right?
Yeah, absolutely. So the last step is deploy your application. So as I mentioned before, this is a Windows 10 device. So it's actually pretty easy to get your application out. So to deploy it to the Windows Store and have it available to anyone with the HoloLens, you simply package your app as you would any typical Windows 10 application. So the same icons, the same screenshots, that sort of stuff which you're used to. One small change is that there is a new concept called the Windows Holographic device family, and you need to target that within your application. So what that tells the store is that your application is holographic ready. And then, based upon that, you have your package, you can push to the store, just as normal. And then the last step is that in the store, there is now an option to allow your application to be pushed to holographic devices. And what's interesting is this feature exists for both 2D and 3D applications. So you can push your traditional UWP applications to HoloLens, as well as your holographic specific applications.
So we are living in the world of holograms. I think holograms become now the way that we can visualize data, we can access our content, we can look at our constructs. Most importantly, in a joint space where the space is the interface, we're actually getting rid of screens and we're actually interacting with each other with the content itself. I think this may not seem very commonplace right now, but hopefully this talk is giving you some energy and you are ready to start developing some HoloLens apps. So thank you very much. This has been our talk, but one final plug.
I hope you join me tomorrow. I'm going to give a session on HoloLens and what goes on in the code, how you develop applications, and specifically how you develop great applications which feature sharing between multiple devices. So please join me tomorrow.
Thank you.